Now, I pulled a problem first thing this morning I want you to look at. I pulled a problem straight from my lab math, just so that you could see what the practical applications are for solving problems that we're going to use some formulas to do, but really this is a problem that may be familiar to you because it's been used a lot. Do you recognize what type of problem this is? It has a triangle, and two of the sides of the triangle are known. We know that the height of this pole is 45 feet, and we know that the transmitter building is 24 feet. This electrician needs to run a line from the base of this transmitter to the top of this pole, but he doesn't know how long the cord needs to be. Do you recognize the type of problem? Anybody? What is it? Do you remember the a squared plus b squared is equal to c squared? Finding the hypotenuse of a triangle, a right triangle. Anybody? Okay? Yeah, sort of vaguely. We have a 90-degree angle, a right angle here. We call one side of this A, we call one side B, and the only requirement is that C is the long side, okay? The one that's directly opposite the 90-degree angle. Got it? Remember it now? Sort of, kind of? So your formula is the Pythagorean theorem. A squared plus b squared is equal to c squared. There's a lot of squares in that thing. And unless you have, perfect numbers, it's really sometimes kind of difficult to solve it. But what you are doing here with this one is we're going to use something called the square root method to solve it toward the end of what we talk about today. But I just want you to be prepared or aware that there are reasons, real-life applications that you will have, you may have, that exist anyway, for solving equations that have squares in them, okay? Have more than one x, have an x squared, okay? And that's the reason we go through this in algebra, is so that you can be educated in how those problems are solved, and maybe, inventing your own situations or solving your own situations. Let's go straight to this page 8 is where we are in our handout. And I want to start talking about section 5.8. Now this is the next section after we've conquered factoring. And you should have conquered factoring by now, pretty much, okay? So this section is going to talk about the quadratic equation, or putting a formula in quadratic equation format. We're not working with the actual quadratic equation yet. Don't go directly to, if you've done this before, don't go directly to solving with the quadratic equation. It's confusing. It's also error-prone. Most people make mistakes in that one. And it's not as easy as actually solving it or factoring it and then solving this way, the way we're going to do first, okay? So what you have here is, you'll notice, so the first time it is a factoring problem because it's got a trinomial and has a perfect square here at the beginning. It has x squared. But the other thing that you should notice about it is that it has equals to something, equal to 0 for the first time. So that has all of a sudden turned our expression into an equation. You got to note that, people, okay? I've had people on tests all the time that try to solve something that doesn't have an equal sign in it. You can't solve anything that doesn't have an equal in it. It's not an equation. So all you can do is simplify. You can only solve, you can only find the actual value for x if you have an equation. So this thing, this trinomial, has been set equal to 0. And that's the difference, major difference in the problems we've worked before and the ones we're starting today. So what do you do with it? Well, you should recognize that it needs to be factored. We cannot solve for x squared, all right? We can solve for x, and we can factor this, and hopefully it'll factor, and we'll get it down to individual x's. So we set up our factor pairs. We look at that second operation, which is a plus. It points us to the first operation, so we're going to use the first operation in both. We're going to go ahead and factor the x squared. And then we're going to go over here and draw our x puzzle, okay? We're going to put the c term, 24, up here in the top. Now, we would have multiplied the a and the c, but I did. A is really 1, isn't it? 1 times 24 goes up here. And the b term goes here. And then I'm going to put my two fractions on the side. And I'm just going to put the square root of that x there, okay? Got it started. And then I'm looking for factors of 24 that when added together are going to give me 11. And at first they might not be obvious to you, right? I mean, I need 24, so I would start, and I kind of did when I was working it because I didn't see it right away. I said 1 and 24, are you here to take a test? Nope, okay, never mind, sorry. Okay, so 1 and 24, and then I'd say, okay, well, 2 and 12, well, those don't add together to give me 11. I got 3 and 8 is the next one that I would think of, and by that time I see it, you know. I go, oh yeah, I should have thought of 3 and 8, but okay, I didn't. So I put a positive 3 and a positive 8, and those are my factors. I'm going slow, but this is something you should have practiced since Monday, and you should, you know, have down, okay? So I've got x plus 3 and x plus 8. I check it. I say x times x is x squared. 3 times 8 is 24. And then I do inside. That would give me 3x. I'm going to write it over here because I need room, okay? So I've got to say inside is 3x, outside is 8x. When I combine those together, I have 11x. So I factored it correctly. No sense solving it if I didn't factor it correctly. And now, look at my equation. It says x plus 3 times x plus 8 is equal to 0. Well, how do you make one of those, how do you make that a true statement? Anything multiplied times 0 will give us 0, right? So if this part of it was a 0, it would be a true statement, wouldn't it? Well, how would I get x plus 3 to be 0? What would x need to be? Negative 3. So look, I'm going to put this down so that because they're going to get more complicated. And then I'm going to solve for x. I'm going to say, well, I would really subtract 3 from both sides, right? And that gives me x is equal to a negative 3. Now, you saw that without doing this math, which is fine. But if you don't see it without doing the math, if you have more complicated, you know, binomials, then you do the math, right? So x is negative 3. That would make it a true statement. If I put in here negative 3 plus 3, I would have 0. And it doesn't matter what this one is, does it? Because it's going to be multiplied times 0. Okay, so what's the other answer, though? Well, this one could be 0, right? What if I could make x plus 8 0? That would also make this a true statement. So what would x need to be in this case? Negative 8. And if you don't see it, you just say, okay, x plus 8 equals 0. Solve for x. Subtract 8 from both sides. X is equal to negative 8. That would also make that a true statement. So in this particular equation, I have two possibilities. X can either be negative 3 or x can be negative 8. I hate that I wrote it that way because you usually write the smallest one first, but I did it backwards. Okay, and I put it inside a set because it is, you know, it could be either or, right? Those are the possibilities. Does that make sense to you? So how do we solve these things? Well, first, key point, they have to be set to equal 0, right? That's the only way we can do it. It can't be equal to 4, it can't be equal to 7, it can't be equal to anything else. It has to be equal to 0. The next thing we do is we factor it, and we set each factor to 0, because these things are multiplied times each other. All we need is for one of them to be 0, and the equation will be true. Let's do another one. This one we got a problem. Starting it right off the bat, it is not equal to 0. But I can get it there. I want to get this 12x to go to the other side. I want this whole thing, I want everything to be on one side of my equation. I already got two of the terms over here, so I'm going to get 12x to go to the other side. So I will simply subtract 12x from both sides of this equation. Well, this side, now I'm going to write it in my format that I know I need to factor in, okay? The square comes first, the x term comes next, and then the plain numeric term comes next. And this side is now equal to 0. And now I'm back to, can I factor that? Can't solve it unless I can factor it. Well, it's a simple trinomial. It has a plus as a second operation, which says use the first sign for both of them. I'm going to factor the x squared. And then I'm going to come over here and say I need 1 times 27 in the top, and I need negative 12 down at the bottom of my x. And then over here, sometimes this is called a diamond. Have you ever heard it called a diamond? Okay, well, this is a diamond format too. All right, so anyway, fractions, x goes at the numerator of both of them. Factors of 27 that will add together, really, to equal a negative 12. Now, how do I know they add? Well, they both have to be negative, right? And so I'm going to have to say a negative times a negative, and this would be a negative plus a negative, so they're going to be negative. And really, that second operation tells you that you're adding them. So what are the factors that you see of 27 that will combine to give me a negative 12? Negative 9, negative 3, right? But why are they both negative, guys? Well, negative times negative to get the positive, right? Plus, both of these are negative, so I know that. Negative 9, negative 3, those are my factors. And I've solved my equation. I've factored my equation. Now what I need is to set each of those factors equal to 0. The first one, what's going to make this 0? Well, I would add 9 to both sides, wouldn't I? The second one, what would make that 0? Well, I would add 3 to both sides. You can think of it any way you want to. 3 minus 3 equals 0, so it's a positive 3 is x. Or you can say, okay, I'm adding 9 here, I'm adding 9 here. That's how x becomes 9. Write it if you need to, but I'm going to start skipping it because you guys are getting more advanced in your factoring, okay? You should be getting more advanced, okay? So what are my solutions? Well, 3 or 9. Like I said, you usually write the smallest one first, but my lab math doesn't care. You separate them by commas and it's happy, okay? Any questions? So far simple? All right, let's see another one. Now this one doesn't look quite so easy. This one is a little jumbled, isn't it? Now the first thing you got to do is we realize that they've asked us to solve. Do you see the word that I'm talking about right up here? Solve means we need x equal to whatever. So the only way I can get x equal to something is if I can simplify this thing down to just a single x. I'm going to have to factor it. It won't factor like it is. This side's already factored, but that side's equal to 4, isn't it? So the bottom line of this, did I just hit some button here? Oh, well, anyway. The bottom line is I need to get the 4 to the other side, and I can do that first, but I also need to distribute this multiplication, okay? So I'm going to kind of do these at the same time. I'm going to say x times 5x gives me 5x squared. And x times 8 gives me a positive 8x. And then I will subtract 4, okay? Well, that's going to give me a minus 4 equals 0. Do it in 2 steps if you need to, okay? But does everybody see that, what I did? You okay? All right, now you can factor it. Now I look for a GCF. I don't see one. I set up my factor pairs. I look at the second operation. It's negative. It says I need one of each sign, right? And then I need x and x factored. I'll come over here and set my diamond or my x puzzle up. And this time I say 5 times negative 4 to get to the top of the diamond. I say, well, the middle of the B term is 8. That's that one. This time the fractions have to have a 5 in front of them because that coefficient of the x squared is a 5. It might have to reduce, right? And then I'm going to say, what are the factors of negative 20 that will combine to give me 8? Well, I know from looking over here, one of them's got to be positive and one of them's got to be negative, right? So I'm thinking, okay, 1 and 20? Nope. 2 and 10? That'll do it. I need it to be a positive 8, so this bigger one has to be positive and the 2 has to be negative. Check it. 10 minus 2 gives me 8. Yep, that'll work, right? So I come over here and I say, okay, minus 2 plus 10. This one will do just like it is, 5x minus 2. It goes in here with the negative one that I just wrote, right? And over here, I'm going to be able to reduce it. I'll divide both of these by 5, so that will be x over a positive 2. Well, this factor just became x plus 2. That should be kind of easy to you by now, right? Shrink this down a little so you can see better. Okay? All right, next. Check it. X times 5x, 5x squared. 2 times negative 2, negative 4. Inside gives me 2 times 5x, which is going to be a 10x. Outside gives me x times negative 2, which is a negative 2x. That gives me an 8x, and that is what I need. So I have checked it. FOIL to check. Don't forget that step, okay? Next, I've got two factors here. It's set equal to 0, so I will have a solution if either one of those factors is equal to 0. So I'm going to set them both to 0, and I'm going to solve for both of them. This time, first one, subtract 2 from both sides, right? Well, that would make that x, that would make that negative 2. So there's one solution. This one's not so easy. I can't do it in one step. I've first got to add 2 to both sides. When I do that, I have 5x is equal to a positive 2. And then I have to divide both sides by 5. X is now equal to 2 divided by 5. We don't care that it's a fraction. You know, get over your fear of fractions and just say, okay, yeah, sometimes solutions might be fractions. What are the solutions? Negative 2, positive 2/5. Any questions on that one? Because your favorite is coming up. We have an equation that has fractions in it. Do you remember the first step always in solving an equation with fractions? What do you do first? Find the least common denominator, and then you're going to multiply by that and clear the fractions. Don't work with fractions. You don't need to. Get rid of them. So I see I've got a denominator of 6 and a denominator of 2. What's my least common denominator? Did you say, somebody said 6? I hope I heard 6. All right, so I'm going to multiply each term in this equation by 6. How many terms do I have? Well, there's one, there's another, there's a third one, and really this 0 is a fourth one. I've got 4 things I'm going to multiply times 6. Now, is multiplying 0 times 6 going to do anything? It's still going to be 0, but we still technically have to multiply it times 0, times 6 to make this legit. So I'm going to say this one times 6. Now, there's not enough room here, and I'm trying to think if I've got enough room to rewrite, and I think I do. So I'm going to do this. I'm going to say that times 6 over 1 minus 3x over 2 times 6 over 1 minus 6 times 6 is equal to 0 times 6. Okay? When I did that, I get these fractions that I'm multiplying together, and they cross-reduce, don't they? This 6 and this 6 turn out to be 1, so I've got x squared. And then over here it's going to be minus, okay, this 2, I'll divide both of these by 2. And I end up with a 3 in the numerator. So I say negative 3x times 3 gives me a negative 9x. Next one I've got is a negative 6 times 6, negative 36. And that is equal to 0 times 6, which is 0. I now have an equation that I can factor a lot easier than working with those fractions, right? So, factor pairs. And I'm going to set the signs. And I'm going to factor the x squared. You remember why the signs are one of each. It's because that second operation was negative. Next, diamond. 1 times negative 36 is negative 36. The middle term is a negative 9. Both of my sides have fractions that have x in the numerator. I want factors of negative 36 that will combine to give me a negative 9. Work your way down if you need to. 1 times 36 doesn't work. 2 times 18 doesn't work. 3 times 12, now that has promise, doesn't it? How would I get it to be a negative 9? Well, one of them has to be negative. I knew that already because I started with a negative up here at the top. Well, negative 12, positive 3. Okay, negative 12, positive 3. I can go straight to my factor pairs and plug those in. So, solutions to this problem. Some of you see it and you know what it's going to be. What are the two solutions? Negative 3, positive 12. How do we know that? Well, x plus 3 would be set to 0. X minus 12 would be set to 0. If either of those factors is 0, the equation is true. So when I subtract 3 from both sides, and when I add 12 to both sides, I get a solution of negative 3 and positive 12. Either would make it a true statement. Okay? Yeah? Sort of, kind of? All right, let's go to some harder problems, okay? A little bit more complicated. This one looks really weird, and at first I wouldn't think, but if they said solve, the only way I can solve is if I can have y equal to something. I got y cubed. I'm not used to solving cubes, but maybe I can factor it and get it down to a y squared or something. But first things first, everything has to be on one side. I'm going to choose to go to the side that has the largest exponent, okay, because that keeps it positive. So what I'm going to do is subtract 36y from both sides. And that's going to give me a y cubed minus 36y equal to 0. Now I'm just dealing with one side. I need to factor it. And the first thing I see is the first thing I must always check for, which is a GCF. What's my GCF, guys? Y. Everybody see it? Factor out the y. What do you have left? Well, y cubed divided by y gave me y squared. Negative 36y divided by y gave me a negative 36. And now, what do you see in this binomial? How do we factor that binomial? What is that binomial? Difference of two squares. Well, that's the easy one, right? Remember the difference of two squares. One of each sign, square root of the first term, square root of the second term. You don't even need to check that one. I don't even require that one to be foiled to check it, guys, because it's too easy, right? Square root of the first one, square root of the second one of each sign. The only thing you have to check is you have to always go to that negative one and make sure it's not another difference of two squares, but it's not. Now, take a look at this. I've got 1, 2, 3 factors, don't I? Don't forget y. So what is y? Well, I'm going to set each of them equal to 0. The first one is simply y is equal to 0. There's no solving there. That one is one of my factors. If y was 0, this entire equation would be true. So it is one of the solutions. The next one is y plus 6 equal to 0. And the third one is y minus 6 equal to 0. Well, this is y is equal to a negative 6, and this is y is equal to a positive 6, right? You good? Are you? Okay, so I have 3 solutions. Smallest one is a negative 6. Next to 0. Next, positive 6. It's just a good habit to get into. Might help you in the next class, okay? All right, so you understand, if you have just plain old y multiplied times something, well, then one of the solutions is going to be y could equal 0, all right, or x by itself. Next. Yeah, because that is one of the solutions. Y could be 0, and it would make a true statement. When you go back to the beginning, if you plug it in, you can see that it would work. If I said 0 cubed is equal to 36 times 0, that would be true, wouldn't it? 0 cubed is 0. 0 times 0 times 0 is 0. 36 times 0 is also 0. So one of the solutions here is 0. Okay? Try it with 6 and negative 6. It'll work for all three of them. Okay? All right. Now I've got everything all over the place. I'm going to move things all to one side, and the side I choose is the one that has the highest exponent. So I'm going to move everything over here to the left because it has an n cubed. How do I do that? Well, I have to subtract 6n squared and add 6, don't I? And then that becomes 0. But if I do that over on that side, then I have to subtract 6n squared and add 6 over here, and everything has now moved to the other side. Now I'll write it as in descending exponents, okay? Highest exponent is n cubed. Next one, that negative 6n squared. Next one, negative n. And the final is plus 6. That's equal to 0. And there is my problem. It looks like it has 4 terms. To factor a problem with 4 terms, I usually try grouping. Oh, I look for a GCF. There's nothing, is there? So I'm going to group it. Now this one's a problem because it's got that middle operation is negative. So I have to keep that middle operation inside the parentheses and add my plus sign. And then I look at the factors, the first two, and I go, what is the GCF? Well, n squared. When I factor out the n squared, I have n minus 6. Do you see it? I would say n cubed divided by n squared. Well, that gave me n. I would say negative 6n squared divided by n squared. That would be negative 6. I just pulled out the n squared. Next thing, I've got a plus here, but the first, there's no GCF. However, the first term is negative, and I can't allow that. I must factor out a negative 1. It changes the sign of everything in parentheses. And now I look at my problem again. I have matching binomials, don't I? There's my factor that is in common. My first binomial. My second one, everything else. Don't forget to always set these equal to 0. Don't forget what you're doing because you get bogged down in factoring, okay? Okay, am I done factoring this problem, or do you see something else? N squared minus 1, right? What is n squared minus 1, guys? Difference of 2 squares. Okay, this will factor again. N minus 6 won't, but this is going to factor into a plus, minus, square root of the first, square root of the second, right? The easy one. Difference of 2 squares. When you have a binomial, look for that to happen. Look for that first, because it is easy. Now I've got 3 factors, don't I? Well, that says I'm going to have 3 solutions. The first one, n minus 6 equal to 0. The second one, n plus 1 equal to 0. And the third one is n minus 1 equal to 0. I got to solve all 3 of those, however you do it. This one I could say n is going to equal 6, n is equal to negative 1, n is equal to positive 1. When it's just simple terms like that, you probably don't have to add and subtract something from both sides to see the solution, okay? You understand how the numbers work, right? You good? All right, I have 3 solutions. I'm going to start writing them. The smallest one, well, the negative 1 is the smallest. The 1 is next. The 6 is next. And there's my solutions to that problem. If you don't write them in ascending order, you're not going to get counted off, okay? Just sort of a little habit I have. Okay, next problem. I'm going to let you see what you can do with this one by yourself, okay? This is a simple factoring problem. You should be able to factor it. You should be able to solve. Carry it all the way through and see what you come up with for your solutions. And if you finish that one, go ahead and try number 8. You can keep on going if you want to and try all of them. It doesn't hurt. Guys, while you're working, if you have questions, ask them, okay? This is a good time. Now, if you are totally lost, look up here and I'll give you some setup help, okay? If you're totally lost, ask me what you're doing wrong. I'll help you with that too. Okay, solution to 7 is up here. Check your work and see if you got it. I know some of you are working on next problems, which is great. But are you okay with this one? Is this good? Did you have it? You good with? Okay. Don't forget the last step. That would be a good point. Okay? All right, let's take the next one then, 8. Somebody tell me, what about number 8? You see first off the bat, the first thing, the thing you always check first. What do you see? Thank you, GCF. You can factor these things without pulling out the GCF and you will be wrong, okay? Your answer will be incorrect. So you must always look at a factoring problem as the first factor that I look for is a GCF. And I see a GCF of 2. Thing is set to 0, so that made that easy, didn't it? At least I didn't have to get everything to the same side. Okay? This one is going to be one of the complex trinomials to factor. I don't forget the 2 that's over here, but I'm going to go ahead and set up these factor pairs, and I don't forget to write it equal to 0, because if I do, I'll forget that last step, which is setting everything equal to 0, setting each factor equal to 0, and solving, okay? So, my minus, I have to put 1 of each sign. I'm going to put an X here, but I'm leaving room to put a number in front of it, because I might have to. And I'm going to draw the diamond, the X puzzle. 12 times negative 1. And the middle term, the B term, doesn't have a number, so that number is 1. Next, I put 12x in my numerators because I have the coefficient in front of the A term, right? So I got to have it. And I come over here and say factors of negative 12 that are going to give me a 1. And it's pretty easy if I start with 1 and 12. This is where this is why I always kind of start with 1, because sometimes that's the one that escapes us, right? 1 and 12, nah, that's not going to work, is it? 2 and 6, no way they'll combine to give me a positive 1, is there? What about 3 and 4? Okay, if one of them's positive and one of them's negative, I can come up with a 1. Which one needs to be negative?
3.
So I have to have 4 minus 3 to make this a 1. I go minus 3 plus 4. And both of these things reduce, don't they? So I can divide this one, both sides, I can divide both numerator and denominator by a 3. That would give me 12x over a negative 1, right? I can divide both of these by 4. I'm running out of room. That's going to give me a 3x over a positive 1. Yeah, thank you. Did I say it and write it wrong? I heard myself say it right. Anyway, maybe not. So I got a 4x over a negative 1, right? A 3x over a positive 1. Did I get that right? Okay, let's put them in the factor pairs. I have I got a different answer. Did I do this one wrong? Nope, I did it wrong yesterday. Are you guys getting the same thing I'm getting? Because now I'm looking at my answer and it doesn't look right. Let me start back over here again, because I sometimes think ahead when I'm working and it doesn't make any sense. Yeah, it is supposed to be positive 1. And these are both divided by 3, and that's 4x minus 1. And this is 3x plus 1. Are we good, everybody? Okay. Make a note so I correct my notes. All right, so the next thing I do is I double check it. 3x times 4x gave me my 12x squared. 1 times negative 1 gives me a negative 1. I have a positive 4x when I do inside, a negative 3x when I do outside. That would give me a positive 1x. I'm good, okay? Next thing, set all the factors equal to 0. Well, the first factor you see is this 2. But is that ever true? Okay, so this one is, I can just say no, not equal to 0. This is 2. There's no way that's going to be a factor, right? It's not going to be equal to 0. I can't use it. So that one's out. 3x plus 1 equals 0. I can solve that one. And 4x minus 1 equals 0. I can solve that one, okay? The next thing I'm going to do is say, okay, solve it. Subtract 1 from both sides, right? 3x is equal to a negative 1. Divide both sides by 3. X is equal to a negative 1/3. Over here, add 1 to both sides. 4x is equal to a positive 1. Divide both sides by 4. X is equal to 1/4. My two answers, if I write the smallest one first, the negative 1/3, and the positive 1/4, okay? Are you okay with this? Yeah? Is it getting early? Are our 8 o'clock classes getting earlier to you? Feels like that to me. All right, good. Let's go on then. The next one, x squared minus 3x equals 18. Everything has to be on one side. I can only have equal to 0. I have an x squared over here. I'm going to subtract 18 from both sides. Are you okay with me doing that? Okay, so let's just do it. Minus 18, minus 18. Well, there's nothing I can combine it with over here. It does rewrite the thing. And now I have a trinomial that looks like doesn't have a GCF, but I can factor it. And I'm going to say 1 of each sign and the square root of that x squared. Now, 1 times negative 18, and the b term is a negative 3. And I'm going to put an x in the numerator, and I'm going to come over here and say, what kind of factors of negative 18 do I combine to get a negative 3? Well, I know one has to be positive and one negative. I'll just start trying them. Do you see it already? You guys see it without doing what I'm doing? You can do that. What do you see, though? 3 and 6? That'll work. Which one of these has to be negative? Is it the 3 or the 6? Yeah, the bigger one has to be negative. I'm going to say if I'm going to get a negative answer here. So I got a positive 3, a negative 6, and then I just plug them in. So easy when I don't have a coefficient in front of that x term, isn't it? X squared. So check it. X times x gives me x squared. 3 times negative 6, negative 18. Inside is 3x minus 6x would be the outside. 3x minus 6x, negative 3x. Please don't forget to check it, or you'll do what I did up there on number, what was it, number 8, and get them backwards because I was in a hurry. Okay? Next, I set these equal to 0. And I solve for x. How are you with this? Are you feeling better? Sort of. Like I told you, factoring has to be really tight before you feel comfortable with the rest of this class. We're over halfway through, but the rest of it, factoring is going to play into everything we do, okay? So you got to recognize the problem types. You got to know quickly how to factor. Check, make sure you do FOIL to check, okay? And then you'll be on your way. Now this last one, I've got an 5x squared is equal to negative x. What I'm going to do is get it all to the same side. The x squared is over here, so I'm going to move my negative x. Now when I do that, I have to add an x. Right? It was negative. I do the opposite addition. So I end up with 5x squared plus x is equal to 0. I'm now ready to start factoring. 5x squared plus x, I see a GCF. First step always, right? X times what is equal to 0? Well, there's two terms in here. If I said 5x squared divided by x, I would get 5x. What happens when I say x divided by x? It's 1. Okay? Okay, that doesn't factor again. So I have two factors, don't I? The x, which that's pretty easy to solve, and the 5x plus 1, which I'll have to work at a little bit. Subtract 1 from both sides. Divide both sides by a 5, right? Now that negative in the numerator usually goes in front of your fraction. Now it just becomes a negative fraction, okay? So what are the solutions? The smallest one is the negative 1/5. The next one is 0. Okay? Are you okay with all that? Because I'm about to leave it and go to something new. Yes? All right. Like I told you, factoring is really important to you, okay? Thank you. So next, let's talk about solving it using a different property. We're going to work at something called the square root property. What you have to recognize, first of all, is that if you have something that looks like x squared is equal to a number, how do you solve for x? Square root of both sides. But you also have to recognize that that number could be a positive or a negative, because negative 2 times negative 2 does give us a positive 4, while 2 times 2 gives us positive 4, right? So when we go over here and we take the square root of something, it has to, our answer is positive or negative, the square root, whatever it is. That's the tricky part, okay? The tricky part in all of this is just saying, okay, I'm going to take the square root of both sides, but my answer over here, could be either positive or negative. And that's what's written up there for you so you don't forget, okay? Now I'm going to look at this one. This one is set up perfectly for us. It has x squared, and it is equal to a number. How can I solve it? I can take the square root of both sides. So when I say the square root of x squared, it's just x, isn't it? I don't need to even write that down, do I? But over here, I'm going to say the square root of 25, and I remember there's two possibilities, right? There's two possibilities. So I'm going to put that plus or minus, and your MyLab Math has the button down there for you to put in, plus or minus, okay? Okay, so what's the answer? Well, what's the square root of 25? It's 5. So x could equal either a positive or a negative 5, plus or minus 5. If I we're writing that in set notation before. Now, MyLab Math's going to take it just like that, okay? Plus or minus 5. But this would be two answers, negative 5 or positive 5. Does give me 25. Negative 5 times negative 5 does give me 25, right? It's the square root property. So all you got to do extra here is remember, you know, it could be plus or minus. All right, look at the next one. This is a little different, but you should be able to take it as far as I took it. And then look at your answer, look at your problem, okay? Well, I'm going to say x, I take the square root of that side, and I take the square root of 12, this side, remembering that it can be either a plus or a minus, right? And then, is that the format I'm leaving it in? Because 12 is not a perfect square. Yeah, no. You've got some perfect squares inside 12, remember? What are they? Well, I got 4 and 3. Well, the 3 is going to have to stay. But the 4 will factor out. The square root of 4 is 2, isn't it? Remember doing this? So what's x equal to? Plus or minus. And then I've got a 2 that I brought out. What got left under the radical? Only the 3. Look at that one and make sure you understand it. Okay? So we pulled out the 2. Could be a plus or minus 2 times the square root of 3. When you've got these things that are stuck under the radical, treat them just like you would a variable, like x, you know? Just that's how we think about it. Don't get bogged down in the fact that it's a square root of something. All you have to do is you have to get all the perfect squares out to simplify it down. Now next, I've got x plus 7 squared is equal to 16. Well, this is weird, but it does have a perfect square, right? I mean, How do I solve for x plus 7 squared? Well, I can take the square root of it. Isn't the square root of x plus 7 squared just plain old x plus 7? You understand that first, right? The next thing is, I've got to take, it's equal to the square root of 16, but it might be a plus or a minus the square root of 16, right? Now, what's the square root of 16, everybody? 4. Let's rewrite this thing. X plus 7 is equal to plus or minus a 4. Now, there's nothing complicated about any of these numbers, so I can simply solve for this, okay? I can say x plus 7 is equal to a positive 4, and x plus 7 is equal to a negative 4, right? I can do it that way. And then I just solve. What would I do here? Subtract 7 from both sides. Well, that means x might equal a negative 3. When I subtract 7 from both sides here, x might equal a negative 11, right? You good with that? If you did it the other way, you could have said, okay, I'm going to subtract 7 from both sides, right? You could have said, okay, x is equal to negative 7 plus or minus 4. And then I would have said, well, x is equal to negative 7 plus 4, and x is equal to negative 7 minus 4. I don't care how you do it. It's both the same solution, okay? But we do come up with two answers here. It could be a negative 3. It could be a negative 11. All right? Are we getting deeper than you wanted to go today at 8 o'clock in the morning? All right, let's take a look at this one. X minus 3 squared is equal to 8. Well, square root both sides for me, and don't forget that you're going to be taking the square root of 8, which does simplify, right? See how far you can get with that before I help you. All right, I'm going to take the square root of this side. Well, that's simple. Now it is just plain old x minus 3. I'm going to take the square root of this side, but I've got to do a plus or minus with it, and it's an 8. When I look at 8, I know that it factors into 4 times 2, and 4 is a perfect square, which is 2, right? This one I'm stuck with. It stays under the radical. So let's rewrite this thing. X minus 3 is equal to plus or minus 2 times the square root of 2. Remember, when this 2 came out, it just gets stuck right in front, multiplied times the radical, right? Remember doing that? So what have I got? Well, I've got x minus 3 is equal to plus or minus 2 times the square root of 2. Well, I can't get this square root of 2 down to a number any way I try. So I'm going to go ahead and solve this thing for x. I'm going to add 3 to both sides. When I do that, sorry, it's going to have to come over here to write it. I said this becomes just plain old x. And this is a 3, isn't it? Now look, you can't add the 3 to the 2, because this is not just a simple 2. This is a 2 multiplied times the square root of 2, isn't it? So it is 3 plus or minus 2 times the square root of 2. Don't tell me it's 5 times the square root of 2, right? That's different. The 2 is multiplied times the square root. The 3 is not. It's simply an extra number added in there, okay? Some of you missed that on the last test. How do you feel about that one? Because I want to do another one. Because this one brings into play some negative numbers, all right? Now look, this is, I'm going to take this, do the same thing we did, okay? I'm going to say 7x minus 2 is equal to the plus or minus the square root of what? Negative 25. Well, that's kind of okay. What's the first thing you do when you see the square root of a negative number? Yeah, and it becomes, when I take the negative out, it's the square root of a negative 1 is what? I. So let's say we take the I out. It has to be multiplied times whatever that radical is, so I'll just write it like that, right? Now, square root of 25, guys, what is it? So I'm getting it better here. Isn't this 5i? I'd write the 5 first, right? Okay, still haven't solved for x, have I? Okay, so let's subtract 2 over here, because I've done all I can do over here on this left side. That's it, right? So let's, add 2 to get rid of that negative 2. And I end up with 7x is equal to 2 plus or minus 5i. Remember, I am not adding a 2 to the thing that's multiplied times I, right? I can't. It's not the same. It's not the same format. It's not the same numbers. It's not like terms, is it? Now, I'm not solved yet. Let me rewrite it up here so you can see clearly what's happening. How do I solve for x? What do I have to do? Okay, so if I divide this side by 7, I divide this entire side by 7. This becomes x is equal to 2 plus or minus 5i divided by 7. It's not complicated. It just looks odd. You're doing the same thing you always do. You just have to kind of say, okay, it's okay to do that. Now, that will not simplify unless, because this is plus or minus, unless all 3 of these numeric terms simplified. If they were all 3 7s, then we could reduce it. But we can't reduce this, okay? Even if this was a 7 and that was a 14, well, actually, that kind of would, no, that still wouldn't reduce. You'd have to reduce all 3 of those numbers would have to for us to do it, okay? All right, that's the most complicated one I have, except I want to go back to the problem I showed you at first. Take a look at my triangle here, and I've got a problem. I've got an electrician who wants to run a cable up the hypotenuse of a triangle. Now he knows the base is 24 feet, and he knows straight up the pole is going to be another, 45 feet. That's how big his tower is. He doesn't know how long his cable is. So you know the formula for finding the hypotenuse of a triangle is the Pythagorean theorem. It is a squared plus b squared is equal to c squared. It's the 2 short sides, squared, multiplied, is equal to the 3rd long side squared. The only requirement when you're setting this up is the hypotenuse, the long side, has to be c, okay? So now I'm going to plug it in. I'm going to say a squared, well, that was 45 feet. Whoops. I'll go over here. 45, I can't talk and do this at the same time, plus 24 is equal to c squared, right? Okay, now I can figure out what 45 squared is. I would type it into my calculator, and I would come out with, I think I got 2025. And I know what 24 squared is. I would type that in. These are not too big for me to do, right? And then when I add those together, I have 2601. So what is c equal to? By the way we've been solving these things, c is going to equal plus or minus the square root of 2601, right? Okay, 2601 is a perfect square. Have you plugged it in your calculator, and do you know what it is? It's 51. Now look at this, okay? Because I don't want to change the rules on you. I want you to see what this plus or minus thing is going to do for you in a real life scenario. The electrician needs to run his cable either positive 51 feet or negative 51 feet. Now guys, is there any such thing as a cable that is a negative 51 feet long? That negative doesn't make sense in this problem, does it? So what is the solution to this one? Plano 51. How do we know that? Common sense. Okay? We still use the same method to solve it. Technically, mathematically speaking, the square root of c squared, or c, could be equal to either a negative or a positive 51. But when you're talking about length, negative doesn't make any sense. So don't get bogged down in, okay, this is the way we're supposed to do it, so much that you forget what makes sense, okay? So in a real life scenario, the negative solution might be just a technicality, okay? Am I making sense to you? I mean, there's no such thing as a negative length, is there? I mean, if I told you the area of this carpet, it's an area of square footage, it's never going to be negative. I'm never going to say, I've got to have a negative 45 square feet of carpet to cover my hall, because that makes sense to nobody. I'm not going to run a fence and tell the guy at Home Depot that I need a negative 261 square running feet, right? I mean, so use your common sense. In real life scenarios, we use the same procedure, but negative doesn't make sense, so the negative is not one of your solutions. Okay, I just wanted to show you that one because it's going to show up on my lab math for you. And that would be how you would look at it, okay? I'm not promising you'll get the same numbers because every one of you should get different numbers when this pops up. All right, next time we talk about, what are we talking about next time? Because we're getting close to the end of this, aren't we? Before you go, I need to tell you that I am